Hello everyone. Today I bring before you an interesting question on geometric series, and the question reads: the second term of a geometric series is negative 30 and the sum of the first two terms is negative 15. Find the first term and the common ratio. We're being asked to find the first term and the common ratio given these parameters. The second term, which is our a sub 2, is equal to negative 30. And then the sum of the first two terms, which we are going to say s sub 2, is equal to negative 15. Now we are asked to find the first term and the common ratio. We need to understand that there are formulas we can use to solve this very problem. And that first formula is if you want to find the nth term, that nth term could be 2, 3, 4, or any term at all of a geometric sequence or series. We use this formula. We say a sub n is equal to a1 multiplied by r, which is the common ratio in this case, raised to power n minus 1, where n is the number of terms. When we say number of terms, we're talking about what we're given in the question. For example, it says second term, right? If we say second term, it means that the number of terms is 2 exactly, right? If they say third term, it means that n is equal to 3. If they say fourth term, n is equal to 4. Now, in this case, it's the second term, which means that our n is equal to 2. All right. So this is the first formula that we're going to use right now to create our first equation. And the second formula that we're going to use is the sum of n terms is equal to, for example, here they say first two terms. So the sum of the first two terms is equal to the first term multiplied by r raised to power n minus 1 all over r minus 1. This is the formula that we're going to use to create our second equation. Why? Because we were given exactly the sum of the first two terms, and we're going to substitute that value here. Okay, now this formula also has a variation. It has another form, which is the sum of nth terms is equal to a sub 1 multiplied by 1 minus r raised to power n all over 1 minus r. It is very important you memorize all these formulas because they're going to be very important in your examination. Whenever you write in your exams, they're going to be very important. All right, now let's go ahead and substitute to start solving. Right here, we were given our second term, which is a sub 2. Now, what's going to happen is that wherever we see a sub 2, we replace it with negative 30. So we have that our a sub 2 is equal to a1 raised to power n minus 1. This is a sub 1 multiplied by the common ratio raised to power n minus 1. So our n in this case is 2. So we say a sub 2 is equal to a sub 1 multiplied by the common ratio. Since our n is 2, we substitute a 2 here for n minus 1. And hence our a sub 2 is equal to a sub 1 multiplied by r, right? Now, what's our a sub 2? Our a sub 2, as we have right here, is negative 30. Hence, we say a sub 1 multiplied by r is equal to negative 30. And this is our equation 1. Okay, we've already created our equation 1 based on the given parameters. Now, we can go ahead and find or to create our second equation, then solve for the values of a sub 1 and the values of r simultaneously. Now, we were given the sum of the first two terms. Remember, I said that this formula right here is a formula for calculating the sum of terms in a geometric sequence or series. And since we were already given the sum of the first two terms, we're going to replace this right here with our negative 15 and then go ahead to solve. So we say the sum of our first two terms is equal to a sub 1 multiplied by r, okay, raised to power n minus 1 all over r minus 1. Now, what is our r? In this case, our r is 2. So we say s sub 2 is equal to a sub 1 multiplied by r raised to the power 2 minus 1 all over r minus 1. Remember that our a sub 2, which is, our s sub 2 rather, is equal to negative 15, right? Yeah, we got it right here, that the sum of the first two terms is negative 15. So wherever we see s sub 2, we replace it with a negative 15. Hence, we're going to have negative 15 is equal to a sub 1 multiplied by r raised to the power 2 minus 1 all over r minus 1. Okay, now what do we do in this case? Kindly permit me to continue with the solution on the left-hand side. I'm going to bring this here so that we can continue from here. All right. Now we have negative 15 is equal to a sub 1. Remember that this is a difference of two squares, right? This is r squared and negative 1. Remember that 1 can be written as a square, right? 1 square is just 1. So these are perfect squares. And if you have a squared minus b squared, this is equal to a plus b multiplied by a minus b, right? Okay, so we're also going to apply the same concept right here to simplify this. Hence, we say this is r plus 1 multiplied by r minus 1. Okay, remember that r squared is a square, and then 1 is also a square, so they can be expanded in this form using the difference of two squares identity, all over r minus 1. Okay, now the r minus 1 on top can cancel with the r minus 1 at the bottom, and what do we have left? Negative 15 is equal to a sub 1 multiplied by r plus 1. All right, we can call this our equation 2. Now, let me copy down the equations and then we can solve them simultaneously. Our equation 1 is a sub 1 multiplied by r is equal to negative 30. And then our equation 2 is negative 15 is equal to, or let me bring the 15 to the other side. I'm going to shift it to the other side. Hence, we have that our a sub 1 multiplied by r plus 1 is equal to negative 15. This is our second equation. Now, let's solve for either a or r. All right. So here we have, we're going to make a1 the subject, or a sub 1 the subject of the formula in equation 1, and then substitute it into equation 2 to solve what we're looking for. Okay, right here we have a sub 1, okay, multiplied by r is equal to negative 30. We want to make a sub 1 the subject. We divide both sides by r. Divide both sides by r. The r's they cancel out, and hence we have that a sub 1 is equal to negative 30 over r. Okay, now we're going to substitute this a sub 1 into equation 2. Wherever we see a sub 1, we simply replace it with negative 30 divided by r, okay? Now here we have negative 30 all over r multiplied by r plus 1 is equal to negative 15. Now let's distribute the negative 30 over r across everything in the bracket. Hence, negative 30 divided by r multiplied by r, we can say this is equal to negative 30 r over r, and then plus negative 30 multiplied by 1. This gives us negative 30 over r. This is equal to negative 15. Now the r here on top and the r below can cancel out. And what do we have left? Negative 30 minus, okay, 30 over r is equal to negative 15. Now, what do we do to remove the r from the denominator? We are simply going to multiply both sides by r, okay? That's the way to do this. We're going to remove the r from the denominator. And if you distribute this r, what shall you obtain? We now have r times negative 30 gives you negative 30r. And then r times negative 30 gives us negative 30r over r. This is equal to negative 15 times r gives us negative 15r. Okay? Now let me continue on the left-hand side. And here we have this r on top of here, and the one below can cancel out. And what do we have left? We now have negative 30r minus 30 is equal to negative 15r. To solve for r, I'm going to move everything with an r to the left-hand side, and everything that has no r to the right-hand side. Hence, we have negative 30r plus 15r. Remember, this 15 is a negative here. So if I move it to the other side, it now becomes a plus 15. Okay, let me write it nicely for clarity's sake. 15r is equal to the negative 30 goes to the other side, and now becomes a plus 30. All right. Now, let's collect like terms. Negative 30r plus 50r is going to give us negative 15r. This is equal to 30. To solve for r, we simply divide both sides by negative 15. We divide the left by negative 15, and then the right by negative 15. Therefore, our r is equal to 30 divided by negative 15 gives us a negative 2. The common ratio in this case is negative 2. Okay, this is your solution for the common ratio. Now we can go ahead and solve for the value of the first term, which is a sub 1. Remember, they said find the first term. Hence, we're going to plug this, we're going to use this very equation right here, that a sub 1 is equal to negative 30 divided by r. Since our r is negative 2, we substitute negative 2 here to solve for a sub 1. Now let's do that. We have that our a sub 1 is equal to negative 30 all over r. And what's our r? Our r is negative 2. Therefore, we have a sub 1 is equal to negative 30 all over negative 2. Good. This negative on top can cancel out with the one at the bottom. Therefore, our a sub 1 is equal to 30 divided by 2 gives you a 15. This is your first term, or this is our first term in this very question. This is your solution, and I believe you understood it clearly. We can also go ahead to prove to check if we are correct or not. Remember that they said that the second term is negative 30, right? So we can solve for the second term, okay, and check if we'll get a negative 30. Since we already have our first term, okay? We have our first term, so we can solve for the second term. So we can say proof. We can say that a sub 2 is equal to, remember we're looking for the second term, so this 2 here means that we're looking for the second term. Our first term, we say this is a sub 1 multiplied by the common ratio, and then raised to power n minus 1. Okay, here we have that a sub 2 is equal to what? Our first term? Our first term is 15, and then our common ratio is negative 2. So this is multiplied by negative 2, and then our n is 2. So we're looking for the second term. So our n has to be 2 minus 1. here, what do we have? We have that our a sub 2 is equal to 15 multiplied by -2. So 2 minus 1 gives you a 1, and any number raised to power 1 is the same number. So we say that our a sub 2 is equal to 15 times -2 gives you a -30. Hence, our solution is actually correct. So we have found that our second term is -30 based on our solution. So the first term is 15 and our common ratio is -2. Thank you for joining me and thanks for being there. See you in the next video and bye.